We are trying to build a pair of smart gloves for football training. This semester's glove prototype focused on using buttons instead of pressure sensors. Pressure sensors offer more range, but cost several dollars each. Button sensors can only tell if you pressed it or not, but only cost a few cents each. Since we have so many sensors, by switching from pressure sensors to buttons, we lowered the overall glove cost significantly. In addition, our new glove prototype can now track 15 points. To eliminate wires, we also experimented with screen printing. Even though the results weren't reliable enough, we will continue to work on this in future semesters. As you can see from this picture, even with an unobstructed camera view, when the field is covered in snow, it can be pretty difficult to spot what yard line the ball carrier is at. We are trying to build a smart football that can be used to remedy these situations for football games. Previous semesters involved us concentrating in understanding GPS data, but this semester we focused on trying to understand the accelerometer data. From our preliminary results so far, the graphs can show if a ball is spiraling. We are working to find other patterns in the coming semesters. We thought it would be relevant to highlight some of our sports-related class projects since it relates to football engineering. This fall, Arvin and Michael took computer vision taught by Professor Herbert. In their final project, using an electric football set, they used multiple cheap webcams to determine a player's location through background subtraction. After determining the moving player's location, an expensive Axis PTZ camera would follow the player as they moved. Michael also took computational photography taught by Professor Efros. Some cool results from that class were Jumbotron overlay using homography and player movement timeline. Please check back at the end of spring to see our next update.